August 23, 1944. Northern France. A German radar post sits on a low bluff facing the channel. The room is dim, yellow, cigarette smoke hanging in a slow sheet. Headphones hum. Paper curls out of a plotting machine. Oberleutnant Max Wachtel's observer leans over the scope, jaw tight, pencil tapping. The V-1 raid should be on schedule. Each pulse jet bomb is supposed to appear as a fast crawl of light across the screen, cross the water, then vanish somewhere over England with a ground flash. Instead, something is wrong. Targets are crossing the coast, then disappearing in open air. No impact markers, no British fighters reported in the sector, no heavy flak bursts close enough to count as a hit, just gone. The observer calls the numbers anyway, voice thin. Count 41 launched, 17 made landfall, 4 still tracking, the rest lost. Wachtel frowns. Lost where? The log clerk copies the ratio, underlines it twice and circles it. 82%. 82% of Hitler's vengeance weapons, erased in a single afternoon by guns that mathematically were never supposed to touch them. The bunker falls quiet. You can hear only the distant surf and the soft tick of the wall clock. No one in that room can explain what just happened. Not yet. This story isn't about the V-1, not about the bombs that fell, not even about the pilots who tried to stop them. It's about what happened after that number, 82%, appeared on a sheet of paper in a German bunker. Because the men staring at it weren't facing an army. They were facing an equation they couldn't solve. They thought the laws of physics were on their side. They thought America was still catching up. They were wrong. What erased their miracle weapon wasn't luck. It was a fuse the size of a man's hand, a device their own scientists had declared impossible. For most of 1944, the V-1 was Germany's pride. A miracle weapon, they called it. Vergeltungswaffe 1, the weapon of vengeance. From the launch ramps near the French coast, it promised a new kind of war. No pilots, no risk, just mathematics and fuel. Each bomb carried 850 kilograms of explosives and flew at nearly 400 miles per hour, faster than most Allied fighters could safely chase. Major General Walter Dornberger and his engineers at Peenemünde had done the calculations. If even 1 in 4 reached London, the tonnage of explosives would exceed the entire Blitz of 1940. It was elegant arithmetic, less cost, more fear, and no human loss. They believed the Allies had no defense capable of catching it. At the start, they were right. Anti-aircraft gunners relied on mechanical time fuses, tiny brass clocks screwed into the nose of every shell. Before firing, the crew had to measure range, wind, altitude, and speed, then twist a dial to the exact second when the shell should explode. In theory, it was precision. In practice, it was prayer. A single miscalculation by 1/10 of a second meant the burst went off harmlessly in empty air. The odds of success were 1 hit in 10,000. Even the Germans' own manuals said so. So when the first V-1s streaked across the channel in June 1944, German commanders expected panic, not resistance. The buzzing sound of the pulse jet engine, that mechanical cough and roar, carried a psychological weight no bomber could match. Londoners would learn to freeze when the sound cut out, because that silence meant the bomb was diving. By every rational measure, it should have worked. In the first week, only 1/4 of the flying bombs were intercepted. By late June, maybe a third. Acceptable losses. Inside Peenemünde, Dr. Robert Lucere, the V-1's designer, boasted that interception was statistically impossible. He wasn't lying. The math backed him. A V-1 flew too fast for conventional radar tracking and too low for early warning systems. Fighters could dive to attack but risked blowing themselves apart if they got close enough to hit. Even if anti-aircraft guns blanketed the sky, most shells would detonate too late or too early to matter. To the engineers, the V-1 wasn't just a weapon. It was proof of German genius. A clockwork engine, a gyroscope brain, a flying bomb that removed the weakness of human pilots. They laughed at British reports of improved accuracy and new defense coordination. Propaganda, they said. Maybe the British were lying to keep morale alive, because in the equations drawn across their chalkboards, nothing had changed. And yet, through July, something began to shift. Observation teams along the coast reported seeing their own V-1s explode mid-air, bursts of flame with no visible impact. Radar crews noticed that the flight path simply ended, far short of London. At first, they blamed sabotage at the launch ramps, then humidity, then faulty fuel injectors. But the field tests came back perfect. Every missile they fired over German territory behaved flawlessly. The only failures occurred when the weapons crossed into Allied airspace. That was impossible. There was no new Allied aircraft, no experimental beam weapon, no evidence of sabotage. And yet the kill rate kept climbing, 24%, then 60, then 82, numbers that made no mathematical sense. Still, in the German command, confidence remained. After all, they told themselves, statistics fluctuate. Maybe luck, maybe weather, maybe British radar tricks, nothing that threatened the weapon itself. They didn't realize what was coming, that the real war wasn't being fought in the skies over London, but inside American factories and laboratories thousands of miles away. Because while Germany was building weapons of terror, America was quietly building weapons of calculation. At the Johns Hopkins Applied Physics Laboratory in Maryland, a team of engineers led by Dr. Merle Tuvey had already solved the equation the Germans thought unsolvable. They called it the VT fuse, variable time. A harmless-sounding name, deliberately designed to hide the truth. It wasn't about time at all. It was about proximity. Inside that tiny metal shell tip sat a complete radio transmitter and receiver, no larger than a matchbox, protected by wax, glass, and plastic strong enough to survive being fired at 20,000 times the force of gravity. When the shell flew close to a target, the radio waves bounced back. A thyrotron switch recognized the echo and triggered detonation at exactly the right distance. The result? A near miss was as deadly as a direct hit. But the Germans didn't know. They couldn't even imagine it. To them, the physics were impossible. Vacuum tubes would shatter, circuits would fail. They had tried, 30 times in fact, and failed every attempt. So when their V-1s began disappearing from radar, German officers kept searching for human explanations, not technological ones. No one dared suggest that the Allies had done the impossible. The irony was cruel. The same arrogance that had built the V-1 was now blinding them to the fuse that would destroy it. Because in war, the deadliest weapon isn't always the one that explodes. Sometimes, it's the idea that no one believed could work. By mid-August 1944, German reporting on the V-1 offensive took on a new tone. The numbers started sounding less like victory and more like an autopsy. Interception rates weren't creeping up anymore. They were jumping. In late June, roughly 1 in 4 V-1s was being stopped before London. By early July, it was 1 in 3. By the end of July, almost 2 in 3. And then, in single bursts, single days, single windows of fire over the Channel, entire salvos were being erased, 82% gone. On paper, that wasn't combat. That was annihilation. And the most disturbing part wasn't just how many V-1s were dying. It was how cheaply the British were killing them. German staff officers were trained to read Allied after-action reports the way a hunter reads tracks in the dirt. You learn from what the enemy brags about, but you learn more from what they complain about. Except here, the British weren't complaining. They were bragging. London's anti-aircraft batteries were reporting kill ratios that sounded like fantasy. Not thousands of shells per bomb. Hundreds, sometimes under 100. That math was physically impossible. The Luftwaffe had done its own gunnery tables. They knew how anti-aircraft fire behaved. They knew dispersion, time of flight, ballistic drop, fuse sensitivity. They knew exact probabilities for a fast, small target like the V-1. Those probabilities did not allow for 100 shells, 1 kill. Not at night, not in rain, not in heavy wind, not at 400 miles per hour. So in the German chain of command, the reaction wasn't panic, it was anger. Oberst Wachtel, commander of Flak Regiment 155W, the unit overseeing V-1 launch operations, sent word down the line. Recheck the missiles. Every single one. Were pulse jets flaming out early? Were guidance gyros drifting off course? Was sabotage finally creeping in? He ordered inspections of fuel quality, weld seams, servo linkages, nose cone tolerances. Teams did spot launches over German-held territory to watch V-1 behavior under controlled conditions. Every test came back clean, no unexplained premature detonations, no catastrophic mid-air failures, no sign of British agents tampering with payloads. The missiles worked. They only failed when they crossed into the British guns. That meant one thing. The guns themselves had changed. But how? Because here was the core problem, and every German analyst knew it. Anti-aircraft guns were stupid. They were brute force tools. You fire a metal shell into the sky. You hope it passes close enough to something valuable, and then you hope the explosion does damage. The only way to increase the chance of a hit is to fire more metal and pray. That's it. That's flak. That's how it had always been. So why were British guns suddenly performing like they could see? Why did they act like they knew exactly when to fire, exactly when to burst, exactly where the V-1 would be? British radar was improving, yes. The SCR-584 sets, American-built, were already known to be excellent tracking radar. But radar doesn't make shells smarter. Radar doesn't tell a fuse when to detonate. Somebody, somewhere, had made the shell smarter. That was the leap. And that was the leap German physics culture simply refused to accept. Because for years, Germany's best minds had said the same thing. A proximity fuse is impossible in wartime conditions. Not difficult. Not, we're working on it. Impossible. Here's why. To make a shell explode when it gets close to a target instead of on a timer, you need a way for the shell to know it is close. That means the shell has to sense distance in real time. In 1944, that means radio. That means you have to build a full miniature radio set, transmitter, receiver, antenna, power supply, and cram it into the front of an artillery shell. Then you have to fire that shell out of a gun at thousands of Gs of acceleration, spin it at over 20,000 revolutions per minute, slam it through shock waves, heat, vibration, and expect the radio to still work. German scientists ran that scenario and laughed. Vacuum tubes are made of glass. Glass shatters. Circuits snap. Batteries rupture. One researcher compared the idea to building a fine pocket watch, loading it into a cannon, and expecting it to keep time after impact. They didn't just think it was impractical, they thought it was childish. So when British guns started killing V-1s without direct hits, when observers saw missiles erupt into flame while flak bursts were still meters away, German analysts ignored the obvious explanation because to them, the obvious explanation was stupid. And war punishes arrogance. While Berlin was reassuring itself that physics made this sort of fuse impossible, American engineers in Maryland and Ohio were already past the "can we do it" stage. They were in the "can we build 40,000 of them today" stage. The project lived under a deliberately boring name, VT fuse, variable time. That name was camouflage. It wasn't variable time. It wasn't time-based at all. It was a proximity fuse. Here's how it worked. Inside the nose of every anti-aircraft shell, American engineers installed a tiny radio transmitter that constantly sent out a signal. When that shell flew close to a target, say, the steel body of a V-1 buzz bomb, the signal bounced back. The fuse's receiver heard its own echo, recognized the sudden spike, and in that instant sent power to a detonator. No guesswork, no timer setting, no prayer. The shell exploded right beside the target, showering it with shrapnel at knife speed. You didn't have to hit the V-1, you just had to get near it. That single change flipped the entire math of air defense. Before VT, to kill one fast-moving target, heavy batteries might fire 2,000, 20,500, even 3,000 shells. After VT, 100, sometimes less. That wasn't an upgrade. That was a new era, and the Germans were watching that era arrive in real time from the wrong side of it. The British immediately redesigned their defense posture to exploit it. They pulled their heavy anti-aircraft guns, 3.7-inch and 90mm batteries, out of London itself and planted them in a dense belt along the coast, aimed not at defending the city, but at killing the V-1s over water. They called it the diver belt. That one move was genius. Reason one, every V-1 now had to fly through a wall of radar-guided VT-fused fire the moment it crossed the channel. The sky itself had become a minefield. Reason two, any VT fuse that didn't detonate in the air would fall harmlessly into the sea instead of landing intact in a British backyard where a German spy might recover it. So not only were the V-1s dying, the secret of why they were dying stayed hidden. Back in German reporting rooms, that made the numbers even more disturbing. Losses spiked, but there was no wreckage to study. Kill rates soared, but there was no captured hardware. British batteries boasted miracle efficiency, but there was no visible miracle. To the men in charge of Germany's vengeance weapon, this didn't look like conventional failure. It looked like sabotage, which is exactly what Oberst Wachtel wrote. He told superiors the only logical explanation was treason. Traitors at the launch sites corrupted fuel lines, tampered servos. He demanded arrests. He initiated inspections so aggressive they approached paranoia. But reality didn't care about his dignity. Every inspected bomb was clean. Every launch crew checked out. Every system ran within spec. So Wachtel was forced into a darker conclusion. One, he did not want to record on paper. The Allies had built something Germany had declared impossible. Something inside those British shells could think. At least, that's how it felt. From his point of view, British guns were no longer spraying the sky blind. They were reaching out, choosing targets, timing bursts with inhuman precision. A V-1 would cross the coast and just cease to exist, not damaged, not diverted, erased. He started hearing the same phrase from multiple stations. They're killing us with math. That sentence sounds poetic now. It wasn't poetic then. It was terror. Because math doesn't run out of courage. Math doesn't get tired. Math doesn't negotiate. If the British, with American help, had turned flak into math, then the V-1 was not a terror weapon anymore. It was ammunition. It was feedstock. It was input for someone else's machine. And a weapon that becomes input is already lost. By the third week of August 1944, the psychological curve had inverted. When the V-1 campaign began in June, London feared the buzzing. By late August, German crews feared the silence. If a missile vanished from radar mid-channel, they knew what it meant. It didn't mean the bomb had struck London. It meant the bomb had never had a chance. That was the point, the exact point, when confidence cracked. Not on the battlefield, not in a speech, not in a duel between fighter aces, in a bunker with a pencil over a ratio that should not exist, 82% in one day. Numbers that, by their own doctrine, were impossible. Numbers that told them, without drama, without propaganda, without mercy, we are already beaten. We just haven't admitted it yet. Berlin, late August 1944. The city is dim now. Windows are taped, power is rationed. You can hear the distant thud of Allied bombers at night like slow, rolling thunder. Inside an operations room, 3 floors below street level, the air is stale and warm. Maps cover the walls. Red strings mark launch sites. Black pins mark impact zones around London. The men in this room are not junior. They are the men trusted to deliver Hitler's vengeance. Oberst Max Wachtel sits at the table with 2 engineers from Peenemünde and an intelligence officer who has not slept properly in days. There is a metal ashtray in the middle of the table. It is already full. They are not arguing. That, more than anything, is the sign. On good days, they argue. They shout. They insist the numbers are wrong. They threaten to have each other transferred. But tonight, no one is shouting. Someone slides a report across the table. Loss rate, 82%. Rounds fired per successful kill, A100. Observation, multiple V-1s destroyed mid-air with no visible direct impact. Note from coastal teams, British flak appears to detonate beside the missile, not in front of it. One sentence has been underlined twice in pencil. No mechanical fuse known to us can do this. No one wants to read that. Sentence out loud. Because that sentence means something none of them wants to admit, even privately. The British shells are thinking. Not thinking like a man, not planning, not hunting, but reacting, choosing the right moment to burst, in real time, in the air. That's not guesswork. That's not luck. That's control. Wachtel leans back in his chair. He rubs his eyes with the base of his palm. He has been telling his superiors for days that the only explanation is sabotage. Traitors at the launch sites, bad fuel, mechanical tampering. That story kept him safe. It meant the problem was human, fixable, punishable. But tonight, his own engineers have ruled sabotage out. The last comfortable lie is gone. So he asks a different question. How? He says quietly. Are they doing this? No one answers. The Peenemünde men glance at each other. Finally, one of them, older, exhausted, nicotine-dry voice, says what none of them wanted in the report. If it's proximity, he says, we've already lost. The room goes still. Because that word, proximity, is not casual. Proximity fuse is the forbidden idea, the fantasy, the joke, the thing German physicists called a fairy tale. Build a tiny radar into an artillery shell, fire it, have it survive launch, have it sense a target, have it detonate at the perfect distance. They had laughed at that. They had called it childish. They had written it off as science fiction and moved on. Now they are watching their own weapon die to something that looks exactly like that fiction, that is not just defeat, that is humiliation. One of the engineers tries to recover his balance. It could still be radar cueing, he says. British gun-laying radar improving battery aim. It does not require the shell itself to react. The intelligence officer shakes his head. No, he says. Listen to the timings. Look at the dispersion radius. The bursts are happening too consistently, too close, too clean. Radar can point guns. Radar can't choose detonation distance in the air. Not like that, not shell by shell. Wachtel doesn't argue. He just stares at the map of London. So much of the original plan was built on a single assumption. Britain cannot stop this. That assumption justified the cost, justified the fuel, justified the propaganda, justified the word vengeance. If that assumption is gone, what is left? What are they doing now? Killing London? Or feeding London's air defense crews practice targets? He looks at the kill ratios again. He understands what those ratios mean in plain language. Before, it took thousands of shells to stop one V-1. Now, with whatever this new fuse is, it takes roughly 100. That is not just increased efficiency. That is multiplied efficiency. That is mass production lethality. That is industry turned into accuracy. He exhales slowly. It isn't rage. It isn't panic. It's something worse, resignation. He circles the number 82% with his pencil. Then he says it. It's over. No theatrics, no table slam, no speech about betrayal. Just, it's over. Not the attack failed, not London is holding, not we need to adjust launch angles. It's over. And everyone in the room knows what he means, because they all feel it in the same part of their chest. The V-1 is finished as a strategic weapon, not because it stopped exploding in London, because it stopped mattering. You cannot frighten a city with a weapon that mostly dies in the sky. You cannot sell vengeance when 8 out of 10 warheads never arrive. You cannot promise Hitler a miracle when physics, your physics, has just been turned against you. Someone finally breaks the silence. What do we report to high command? Wachtel doesn't look up. Mechanical unreliability, he says. They all understand why. You do not send a message upstairs that says, the British have a shell that thinks and we don't. You do not tell Berlin that the enemy just leapfrogged your science with something you said could never exist. You call it mechanical unreliability. You blame wind shear. You blame launch angle drift. You blame bad welders. You lie. Because the truth is worse than failure. The truth is shame. And underneath that shame, a colder realization settles in, one that none of them will write, but all of them can see. This is not just about the V-1. If the British, with American help, can mass-produce a fuse like this for anti-aircraft shells, what happens when that thinking fuse ends up on field artillery? What happens when ground troops start firing shells that explode the instant they get near men, not tanks? What happens when this impossible idea spreads? No army, no bunker, no column of infantry survives that transition unchanged. The Peenemünde engineer closes his notebook. We're not catching up, he says. Not this year, not next year. Then he says it even flatter. Not ever. That sentence lands harder than any bomb. Not ever, because not ever means this is no longer a race. A race implies you might still win if you run harder. Not ever means the race is already finished and you are still sprinting because no one has told you the crowd went home. The intelligence officer rubs his temples. So what do we do? He asks. Wachtel answers without emotion. We keep firing, he says. And that is the last cruelty. They all know the campaign has failed. They all know the promise they sold. London will break, is dead. They all know the weapon that was supposed to terrify civilians is now getting harvested out of the sky like scrap, but they will keep launching anyway, not to win, to delay the moment someone above them has to admit defeat out loud. History loves to dramatize battlefield courage. It rarely lingers on this kind of moment. A quiet room, a circle around a number, 4 men realizing they are already ghosts in a war machine that hasn't publicly died yet. "It's over," he said. And in that instant, it was. The silence that began in that Berlin room didn't stay there. It spread through cables, memos, rumors. By September 1944, everyone involved in the V-1 offensive knew something was deeply wrong, even if no one dared write it. At the front lines, the launch crews noticed it first. They would fuel the missiles at dawn, check the pulse jet ignition, and watch them vanish into a sky that gave nothing back. No word, no glory, just fewer explosions in London's papers. The British, meanwhile, had transformed their defense into a factory process. The diver belt, as they called it, was working like clockwork. American-built SCR-584 radar units tracked each missile automatically, feeding its path to the guns. Gunners didn't have to guess anymore. They just loaded shells. Each one carried the same secret, the tiny radio brain in its nose. A VT fuse. Those letters, VT, meant nothing to the gunners. They were told never to discuss them, never to let an unexploded shell fall into German hands. Even their officers didn't know exactly how the things worked, only that they worked. In less than 2 months, interception rates stabilized above 80%. The nightmare of the V-1 was ending almost as quickly as it had begun. And for London, that meant something bigger than statistics. It meant sleep. It meant that the sirens no longer ruled the night. It meant that entire neighborhoods could breathe again. General Frederick Pyle, head of Britain's anti-aircraft command, later said, without the VT fuse, the death toll in London would have been 4 times higher. Tens of thousands of lives, spared by radio waves and circuitry smaller than a teacup. While the British celebrated survival, America celebrated production. Factories across the United States were turning out 40,000 fuses a day. Over 100 separate companies took part. The work was compartmentalized so tightly that no single plant understood the full design. One made glass batteries, another molded plastic casings, another wound copper coils thinner than a hair. By the end of the war, they had built more than 22 million proximity fuses at a cost of over $1 billion wartime dollars. Crosley Corporation in Cincinnati, a company that once made refrigerators, now produced 16,000 fuses every day. Most of the workers were women, the same women whose brothers and husbands were fighting overseas. They didn't think of themselves as inventors. They thought of themselves as hands helping the war end sooner. In Germany, that concept, the fusion of science and mass labor, simply didn't exist. Peenemünde had scientists, not assembly lines. It had brilliance, not redundancy. It had men designing miracles, not women producing millions of parts. That difference wasn't cultural trivia. It was the reason one side's weapon worked and the others didn't. When Germany finally collapsed in May 1945, Allied forces began interrogating the scientists behind the V-1 and V-2 programs. They all gave the same answers. They suspected British radar had improved. They thought gun crews had become better trained, but none of them, not one, had guessed the truth. When shown an actual American VT fuse, they were stunned. Some refused to believe it was real. Others asked if it had been built after the war as propaganda. One physicist held the device, turned it over in his hands and said quietly, "We considered this impossible." And that was the humiliation. They hadn't been defeated by a weapon they could see. They had been defeated by an idea they had laughed at. During the Battle of the Bulge that winter, German troops even captured an entire American ammunition dump, crates of artillery shells stacked neatly under snow. Every shell in those crates carried a VT fuse. They were holding the answer to their own mystery, and didn't recognize it. Their own experts had declared such a thing physically impossible, so they didn't even bother to open the shells for inspection. They left them there. That is what pride does. It blinds. For the Allies, the VT fuse became more than a tool. It became a symbol of how a democracy fights war, not through one man's genius, but through 1,000 anonymous collaborations. Dr. Merle Tuve, the quiet scientist who had led the project, later said, "We won because everyone agreed to be small parts of something enormous." That line, too, was a kind of verdict, because while Germany chased the perfection of the individual, America mastered the multiplication of the collective, and the cost of that difference was measured not in factories or budgets, but in lives. By September, the V-1 campaign was finished. Of the more than 9,000 launched at Great Britain, only about 2,500 reached the city. They killed 6,000 civilians. A tragedy, yes, but without the VT fuse, it might have been 25,000. The war moved on, to the V2 rockets, to new horrors, to new headlines. But the quiet victory of the VT fuse remained buried under classification for another year. When it was finally declassified, the U.S. War Department called it one of the most important weapons of World War II, surpassed in effectiveness only by the atomic bomb. That statement was true, but incomplete. Because the real success wasn't technical, it was moral. The proximity fuse didn't win because it was clever. It won because it represented something larger, a society capable of turning science into cooperation, and cooperation into survival. For Germany, the cost was not just military, it was existential. They learned too late that intelligence without humility is just another kind of blindness. The weapon they had laughed at, the tiny, impossible fuse, had destroyed not just their V-1s, but their certainty. It had rewritten the equation of war, not genius versus genius, but system versus system. And when the system itself thinks faster than pride can react, the outcome is inevitable. Listen to the language Germany used: vengeance weapon, statistical impossibility, London will break. Now, listen to the language that ended it: coil winders, vacuum tubes, assembly quotas, 40,000 units a day. That's the real story. The VT fuse didn't just make anti-aircraft guns smarter. It exposed what modern war had already become in 1944. Not a duel of pilots, not a contest of heroic will, a race to build thinking machines faster than the other side can understand them. Here's the part almost no one says out loud. The Germans weren't defeated in the sky. They were defeated in the factory. They weren't outfought. They were outproduced. And not just outproduced in volume, outproduced in humility. Because to build that fuse, America did something Germany, under its system, could not do. It let thousands of ordinary people become part of a single mind. University physicists, radio companies, women on assembly lines, soldiers in gun pits on the English coast. No cult of one genius, no myth of one savior weapon. Just a chain, invisible, relentless. Germany kept believing in miracles: the miracle rocket, the miracle bomb, the miracle last-minute solution that would terrify London and force the British to bargain for peace. America didn't build a miracle. America built a process, and that process turned into 82%. That number on the paper, the one that made that bunker in France go quiet, the one that made Oberst Wachtel stop lying to himself, that number wasn't just kill efficiency, it was a sentence. It said, "You are already finished. You just haven't admitted it yet." So let's be honest about what actually died in August 1944. Yes, thousands of V-1s. Yes, a campaign of terror. But something else died too. The idea that brilliance alone could still steer a war. After the VT fuse, war was no longer about the smartest man in the room. It was about whose entire country could think at once. That's the part that still makes people uncomfortable, because it means victory is no longer courage or honor or the better pilot won. It means victory belongs to whoever can turn their cities into machines for killing. Factories as weapons, logistics as weapons, electrical power as a weapon. That's what Wachtel felt in that room when he circled 82% and whispered, "It's over." He wasn't just seeing defeat, he was seeing the future. And here's the question that future leaves for us. When a nation can erase a city, or erase 82% of an enemy's weapons in one afternoon, not with bravery, but with process, is that brilliance, or is that just a colder kind of cruelty? You tell me. History remembers the sound of the V-1, that hateful buzz, that falling silence. Almost nobody remembers the other silence, the silence in a bunker when 4 men realized the war they thought they were fighting was already gone. There's a strange kind of silence that follows understanding. Not defeat, understanding. It isn't loud, It doesn't come with explosions. It's the silence of men realizing they have been fighting the wrong kind of war all along. For Germany in 1944, that silence meant something more final than loss. It meant the end of an era, the death of the idea that a handful of brilliant men could outthink an entire industrial democracy. It meant that genius, without humility, was no match for production lines powered by shared belief. The American VT fuse never had a parade, no victory posters, no medals, no statues. Its story lived in classified archives for years. Too technical to glorify and too mechanical to mythologize, but its impact was everywhere. Every radar-guided system that came after it, every missile defense, every smart bomb, every automated trigger, began with that little radio brain born inside a shell. And the irony? The Germans had chased the future so hard, they ran right past it. They had the first jet fighters, the first cruise missile, the first rocket to touch space. And yet, they lost to a 5-inch piece of circuitry that worked because it didn't need to be perfect. It only needed to be possible. Maybe that's the truest legacy of 1944. Not that America's science was better, but that it was braver. The courage to try something absurd, to fail 30 times, to keep building until failure itself ran out of breath. In the ruins of Peenemünde, when Allied investigators arrived months later, they found blueprints of every German wonder weapon neatly archived, everything labeled, categorized, preserved. Except one thing, a working proximity fuse. Because no one there had ever managed to build one, they had never believed they needed to. That small absence said everything. They had lost not to an invention, but to a mindset that said, we can make this work, even if the math says no. That's how wars end now, not with the bravest soldier, but with the most flexible thinker. And maybe that's why this story still matters, because every time we talk about technological superiority, we should remember what it really meant in 1944. It wasn't about intelligence defeating ignorance. It was humility defeating arrogance, collaboration defeating isolation, minds connected by wires instead of borders. The VT fuse didn't just save London. It quietly proved that the strongest weapon of the 20th century wasn't the bomb or the plane or the rocket. It was cooperation, engineered. So when you hear that number again, 82%, remember what it really measures, not destruction, understanding. Because in that bunker, on that day, when the Germans finally saw the impossible become ordinary, the war of invention ended, and the war of systems began.